What is reCamera? The first fully open-source, programmable AI camera powered by RISC-V. reCamera is in modular design, along with the expandable sensor board and interface backboard, all in a compact size. Traditional setups are bulky and not flexible for integration. We hope to create a standalone camera platform. It's compact and power efficient. Moreover, easy to be integrated to any platform. Hardware is actually making reCamera special. The modular design gets full potential of the mix, allows you to change any interfaces and any camera sensors to suit a specific application needs. The complete mechanical design provides an excellent cooling, optimized for deployment in production environments. The core processor board is wrapped by the metal mainframe, ensuring heat dissipation and maintaining temperatures below 50 Celsius at room temperature. Rubber rings are securely placed in the grooves on the front and back of the device. You can active quick mounting for seamless integration with any camera accessories, leaving a quarter-inch screw like a tripod. Your camera is already a computer. It runs a Linux operating system in chip. You can access the system in any ways, so hardware is the lower limit, while software defines the upper limit. We have integrated no write for no-code workflow. Select Node module, configure the node, and deploy with one click. reCamera comes with native support for Ultralytics 0, access real-world computer vision across industries such as object counting and heat maps. With all highlights above, it is super easy to bring our reCamera to any equipment, robot arm, gimbal, and pocket device. We prepared 4 versions of reCamera with different RAM and wireless. It's time for you to define the next, most advanced AI camera. Join our Discord group to discuss further and get the latest updates.
Hey. Hi guys, I'm Ethan. How's it going today?
Hi guys, welcome back to our channel. So here's our every week's live stream C Studio making next Gadget. I'm Jenny, the AGI product marketing, and here's Ethan.
Hi everyone, nice to meet you again.
Yeah, I'm pretty sure everybody's doing good. So we are also hanging on, and to be honest, we are really excited about today's live stream because for today's topic, we'll discuss more about the Edge AI in robotics. Yeah. So how our NVIDIA Mini Jetson computer empowers the robot and the machine system to make everything under control.
Yes. So we have many robotic partners coming today. Also, their products are coming today. So from this many friends has sponsored this live stream with their products.
Yeah, so we also see there's many demos showcasing here. So why don't we just take a first look of the shop video to see what's going on today?
Maybe someone has worked it already, but let's go through it again.
Yeah.
Make sure everyone knows it.
OK, let's start it.
Okay, so I think all of you have already seen
These amazing demos.
These amazing demos.
Yeah.
They will all show up in the following schedule. First, I think most of you have already seen this small robots.
The robot basement moving, and also we have the robot arms. So we also bring our newest Jetson product, right? The reComputer Mini series.
Yeah. And also we will have a lucky draw for it. A really big lucky draw.
Yeah.
As you know, Jetson is always very expensive, and what we are going to give away is also the top of it.
Yeah. But right now, we'll just hold this giveaway towards the end of the live stream. So you see how to get a chance to win the lucky draw, and which is estimated selling in the late December, which is our reComputer Mini. So just stay with us, and we'll give you more surprise.
Yeah, stay with us till the very end.
Okay. So let's go ahead for the demo part. For the robotic applications, we've tried so many wikis and demos in this long period that we're using our reComputer rethink series.
Rethink series has gone through for a really long time, from the first reComputer to maybe reComputer industrial, and further it goes to reserve industrial, but well, it's not in our today's topic. So I think within all of this reComputer series, reComputer industrial is the best one. Maybe until reComputer Mini shows up, is the best one for robotic. Currently, it's still the best one for robotic applications. So Echo comes here. So you can see that in my hand is the reComputer industrial. Why is it so suitable for robotic application? Is it because it has rich interface compared to the other two series. And it was designed for control. It was designed for control, for industrial control your manufacturer line, control everything. So let's take a close look at Echo. So within here, it has RS485 connectors, CAN interfaces.
Yes.
And also there are 2 other Ethernet ports. So it's really suitable to connect the 3D lidar and maybe depth camera, and also connect the CAN signal into it to control the robotic this chases or other things.
Okay.
So
this is kind of the cool demos that we are doing in the previous demos. Like we using the moving robotics to do the navigation, the mapping, this kind of functions. For the basic.
Yeah.
Right.
So just a summary of why people prefer industrial is about CAN, a fixed, a really stable connectors, wide range of power input. It could accept 12 to 36, right?
Okay.
And also a 2 Ethernet port will give you an additional one, a spare one, after you connect like a lidar.
Oh, that's nice.
Many computers just connect a 3D lidar and no Ethernet available.
Okay.
So maybe
I think maybe our newest product will change this kind of.
Yeah, we will change this shortly, but let's spare it later.
Yeah.
So let's take a close look how this whole things work. So Frank, can you show us the logic
diagram?
Yeah,
we want to show the technical architecture to you guys to see how we go from the data transmission to build this kind of awesome and the awareness of the robotics and also the mapping and navigation functions.
So there are 2 parts. So first is let's take a look at our hardware diagram. The hardware diagram is really simple. Really simple.
Okay.
So the reComputer industrial is the main character within it, and connect Ethernet to the 3D lidar, connect CAN to the chassis, and then everything is almost done.
Okay.
Indeed, we have a router built in, but it's for network connection.
Okay.
It's not a really necessary part here.
So for this one, we just need to pay more attention for the control part, right?
Yeah. And afterwards, let's take a deep look at how it's mapping. So we have used a 3D lidar the 3D lidar is generate a 3D point cloud.
Okay.
It's sometimes too massive for a robot like this because it only runs on plane.
Yeah.
So generally, we will put compress into a 2D point cloud. So after here, you got a 2D point cloud like a traditional 2D lidar, but the data is more rich and powerful. Someone may think after compression, this higher level point cloud data is useless, but when you are going to climb a ramp or maybe go upstairs, you will need that data of higher Z level. So 3D point cloud is still more powerful than 2D lidar.
So it means that you contain the depth information in that?
Yeah. Okay. So you could like predict what kind of obstacles will be upstairs before you goes on.
Oh, yeah. That's nice.
Okay. So and after that, it goes to our, we use this open source G mapping rows packages, and then and also we take the post data from the chases provided from our partner Hexmoo, their echo chases. They post their position data and this data back to us, and all this data combined together, we get a map. Yeah, and so let's take a full look at what this control logic. So after getting the map, we could use both global mapping and local mapping. So I think in here we use DWG for local mapping, while A* for global mapping.
I'm not so sure about the local mapping and global mapping. Do you mind just explaining what's the difference for that?
Sure. So can we just switch to the control screen of our echo? I think it will be more clear. So it's more like if you have played RTS game like StarCraft or maybe Age of Empires before, you will know that sometimes you can only see the things around you.
Yeah.
There will be a fog. It's called war fog in the other parts. It's also the same to the robots. they can't see the things far away.
Okay.
They know it before. They have a map in their mind, but they could plan a route to it. But when you are going through to the endpoint, you will discover something may different to your memory, like someone standing in the middle of the road.
Okay.
Yeah. So that's where the local mapping works. It will takes the real situation around it and planning for the local solution, while the global mapping will tell him what's the best solution according to the original map. But it will update its routine during it goes. So echo, do something. Just go. Let's make a routine.
Okay, so you can see.
Yeah.
There's a.
Yeah, so it goes, we set an endpoint and the echo will just route to the endpoint. And also, you can see that, this is the 3D point cloud original looks like. Many point clouds, but...
so you can see the real results for the robotics moving in this area.
Yeah,
and also plan the route for it, right?
Yeah.
Okay.
And this point cloud will need to be compressed to a 2D one, that's as we mentioned before. So, yeah.
Okay.
Also, besides the computer industrial, we have also seen many other open source hardware options.
Right.
Yeah.
So like the RISC-V, this kind of rising architecture?
Yeah. Jetson is an ARM architecture. Originally, people are developing robotics on x68 platforms and then ARM platforms. On these two platforms, I think the ecosystem is really maturing now. But recently, RISC-V chips are.
It's very popular.
It's very popular.
Everyone's paying attention on it.
There has been many other chip options here. So like this one, so showed here. What we have today also here is a RISC-V chip called a front spacemate. It provides two tops AI power, while also it has really rich interface, powerful CPU, but you know, the only one back end is the shortage of this ecosystem. So we have tried a lot of robotic application packages on it. So like currently it's running a mapping. So it's using a 2D lidar, and it runs a mapping here. You can see the point cloud result. This part is fine, but there's also lots of problem left to be done. Like many robotic partners haven't compiled their own packages or their own libraries onto RISC-V platforms. So if any of people is also interested in RISC-V application, we are here raising your attention that there are still many things need to be done. So we are raising the attention to open source community, hoping someone could join here and building this ecosystem together.
It's definitely worth it to try it, and you can join this ecosystem to contribute together, right? Okay. So, all right, so we talk about so many possibilities in the first half of the live stream. So how we deal with the robotics application based on what we have. But actually, at the beginning of the product creation, the whole rethink series is not really designed for the robotics. We want to make a common developer kit, right?
Yeah, reComputer Industrial, well, it could be used for robotic, but it was more originally built for manufacturer. It was designed for being deployed in a factory. So today, I think today we bring you the new reComputer Mini series, and also a really exciting demo. So you can see Saber is here. Say hello to everyone.
Can we wave the hand to the audience?
Okay, so I think so. Let's Saber do something for us. Try grabbing the ping-pong pad and catch some balls if you can. So besides Saber here is our reComputer Mini. It's pretty small, and it's controlled directly from the here.
We should give it some time because it's still just trying to wave the hand. That's nice.
Nice catch.
You know, in China, playing ping pong is like everybody can play the ping pong, but actually for now we want to try to train the robot arm to do also the Chinese things, right?
Yeah, but it's a bit hard. We have trained for days, but it seems.
Yeah, it's just the beginning, so
it seems
not bad.
He's still trying to.
It's trying to learn, so give it time.
And trying to get used to its new arm. Okay, nice try, and I think that's part of this. Let's put back. So at here we also have a new friend. I think our new friend. I think not our new friend, our old friend from NVIDIA community, Dustin.
Yeah, Dustin, the application engineer. So can we just reach the Dustin online to see if he's joining?
I think he is still in our live stream. Maybe not haven't joined our live stream yet, but whatever, we could go on, and whenever Dustin is ready, he could join us, and we could discuss more about this part. So that's maybe
it's pouring water, pouring cola for us.
Well, Saber is pouring a Coca for us. We could talking about something more like.
Well done.
Well done. Thank you.
Thank you.
And this is indeed a 7 degree of freedom.
Okay.
So it's originally a 6 degree of freedom. So, well, it has some additional grappers, so it's 7. Well, okay, I think he has done all the job. Good job, boy. Back to rest. So many people may be interested in how we have done this. So I think it's time we need to introduce our
the newest product.
The solution.
Can we show the technical architecture first to see how the VR and the robo demo works?
Yeah. So let's switch to the VR vision.
I think right now the audience can see the VR view of the architecture, right?
Yeah, and I think you can see. Say hello to everyone, our pilot. Say hello to everyone. Okay, I think you have seen him. We are using his vision from Meta Quest 3 to make the live stream now. So Parker, show our architecture here.
Yeah.
Okay.
We are just trying to find. We are just trying to find it.
So we are not using a traditional another robotic arm to some solution are just using another robot arm. It will like if you are going to control a 7 degree of freedom robot, you will use another 7 degree of robot arm
to assist with the robot.
Yeah. Someone is going to lead the other arm, and this arm will just try to copy the action of the other one. But well, today we're using this VR solution brought by our partner Xmoo. They have write this VR solution, or maybe AR solution. I think this is an AR solution,
yes.
Or maybe XR, whatever. So according to this architecture, they are using web technology. Yeah, because Unity. This Unity, Steam VR, the traditional VR solution, only video VR, is still not available on ARM architecture Jetson. There are still many drivers missing, so they have to migrate it. Maybe still need some time. We have to wait. Well, but web technology is very mature today. So they have get the pose and position data from the Quest 3 and post it onto a web server, and then the Jetson also opens that web server and get data back down here.
Okay, well, so the data will be transferred. So the whole solution is transferred from the ROS package to the robot arm, right?
They connect. They get the data from the cloud and connect it into the rows, post into ROS topic, and well, everything's done. Then the other parts should be really familiar to every robotic engineer. You got the rows, you got everything. Yeah.
Got it. So
I think that's I think many people about software is indeed really simple. It's indeed really simple. Our partners will also open source some data and some projects related to this project onto I think maybe GitHub or maybe GitLab, whatever. Later, we will post this in our Discord. So if you are also interested in this solution, join our Discord and stay tuned.
Yeah.
And so I think it's time, maybe back to reality.
Do you want to reach out to Dustin first, or we introduce the reComputer Mini first?
I think Dustin is already here. Okay. So I think Dustin must have some questions, want to discuss with us about this solution. Okay. Hi.
Hi, Dustin. Oh, hi.
Hello. Can you hear me?
Yeah.
Hi.
Hi.
How are you?
Hi. How are you? Yeah, I can hear you now. How are you doing tonight? Or today? Yes. I had not previously heard what you were saying because the mine was on mute. I'm sorry. Your stream muted again. I can't hear it.
side? Anything?
Yeah, on your side, it keeps muting, so I can't hear what you say, but I can hear you now. Maybe it's how you're transmitting or whatnot.
Okay. Well, I think now it's okay. So
Yes, I can hear you now.
To discuss more deeply about the demo.
Sure. Yes, that's great. Thanks. That's a nice arm. Did you guys build that?
No, it's from our partners. Our partner is called Hactmo. It's nice. It's really near to our company.
Yes.
And
that looks really nice.
We test with our Jetson Mini here, really tiny.
Okay. Yeah, you guys did very nice with the design on that. Thank you.
Yeah, we will introduce more deeply. We will take it apart and see how the hardware is inside.
Cool. Yeah, it would appear like you made a custom carrier of your own, perhaps, because the port design is different. Yeah, good job. Yeah, appreciate all your guys' support with everything in the AI community, all the tiny ML stuff you're doing. Yeah, you guys are great.
Yeah, this carrier board is really powerful. Not only the interfaces on it, but it could directly they could directly be applied with up to 60 volts DC input. So it could work directly in any robotic system.
That is interesting, isn't it? Those boards do prefer to be stepped up to like 16 to 18 volts. And is it the Nano Nano that you have in there now, or the NX?
Orin NX 16 gigabytes.
Nice.
Design also do a lot of work in this heat dissipation. The heat sink, we have controlled heat really well. Yeah.
Very nice. Yeah. It's nice to have options for all of them. But yeah, I assume like the whole thing's basically metal, it looks like. So
aluminum frame. Well, the only pity today is that we still have to use web technology to solve this data communication. Just in our previous email, I have asked how about the Unity and SteamVR. Well, after the test, no.
Yes, and we've all been like working on all that, and along with the state-of-the-art researchers, and everybody's kind of working on it together. And they also now seem to be considering much more the actual deployment of it as well, and making these mobile, which is, I believe, really where you see these type of like edge computer systems coming into play in the near future a lot. Yeah, because now that we got the manipulators working, and you need to like take it on the go. So right now yours is on this cart, presumably, so you can move it around, but it'll be on some robot base. Yeah, whether that's a humanoid or a small like UGV or whatnot. Yes, yeah. But the arm from your partner is very interesting too. So
the arm is one of partners.
Yeah, those have been coming down in price a lot as well. So that's great to see.
Yeah, we will also bring it into our next NVIDIA exhibition. So we will show this demo continuously.
Yeah. Have you guys started to make anything with the QDD motors that like the humanoids and those are using?
QTT motors, I think not yet. But
yeah, they're starting to become more used in like maker DIY communities than like the Disney BDX robots or those as well. They're much like the R2D2 scene was popular with those little mini BDX, or you can find those 3D printed as well, and some of those are starting to use that. But I think that is some core tech that enables those humanoids and those advances with that, and starting to see some like Chitoku and some of our other colleagues have been looking at using those as well. So I wouldn't be surprised if soon you start to see those popping up, and will enable lots of other cool designs like this. So what kind of learning algorithms did you settle on after I think you initially had asked about open VLA or like point you to that. And now we're looking at like the diffusion policies and the other lay robot. Been working with them. So just like trying all of this stuff and training our own. That's what we're getting into now. Training your own VLMs or VLAs and
That's the
the whole
part we
thing.
are going to work at.
Yeah.
That's the part we want to work next. So firstly, we have to have an arm. Now it's here. Then we need to get some data for training. Then that's how the VR works.
Yes.
So and in the following weeks or the following years and maybe the following months, we will still going to get more demos around this set. We will have
Yeah.
you have mentioned and many things new. Yeah.
This kind of generate AI models on it or some multimodal.
Yeah. We will try
That's
it.
good. Yeah. Okay. I think at current state, I think I would consider using Lay Robot for it, and we're working all around that because we started to. Chutoku has that set up, and we're looking at some additional policies for it, the language model stuff, and would enable us to all like collab because that's what they're doing, and we just had to like get it all working on Jetson and like figure that out. Otherwise, there's so much other these like research projects out there that come with like the latest of the policy, but they must always have their own simulator, and so you could go get this working like that in its own or in ROS, something like that. Have it be so somebody can still take advantage of it would be ideal, and then we can all just like adopt that much more quickly. I feel. So what do you think you're going to train it to do in particular? Play ping pong or pick up the balls, or what are you looking to do with it?
Well, I think the first thing may still be the open VLA. That will be pretty simple, grabbing something out of and afterwards, I think
should be pretty simple. Yeah, that's what I thought too. Yeah, and it might actually be.
Well, playing ping pong will be the next step that we are considering, but it will need really many data. Our teammates will sign up for a robotic competition every day evening. They will play ping pong with this arm and we will collect data from it day by day.
Okay. Yeah. Oh, that's good. And I think that is the right track, whether it ends up being, well, what I'm looking at do is doing a smaller VLA, like a mini VLA that's maybe 3B or Llama 1B, something like that, with a easier workflow that's more meant for, like you said, every day people coming in and doing it and just being able to log those episodes easily, the pipelines trimmed down. So the VLA architectures themselves are great. The 7B size, especially in the NX, will be too slow. Like the OpenVLA 7B got that to 3 FPS on AGX OREN. And I believe that is like right at the cusp of it being able to work, as what some of the researchers used in their paper and the findings and stuff. But in reality, that's not fast enough to have it be. It needs to be more like 10 FPS. And then there's other research going that has like a fast, low one where they started working in absolute coordinates instead of relative ones, so that the VLA can run maybe once or twice a second and say, like the robot arm, just go to this coordinate, like the handle on a coffee cup or whatever, go to this spot and pick up the ball, as opposed to every individual frame doing it. There's lots of different techniques that people are trying, and then you can go and try too. Anybody can, and investigating this stuff.
Techniques and the solution you have mentioned, I have seen many of people are trying different ones. Some of them are just mentioned. So this is still under development. So I think more the more close we will go to speed.
Some of them are starting to do it with 3D different encoders. That does seem to start being occurring, where like you can just go off and make your own kind of. It is good to have the training frameworks there, so you can automate some of that. Perhaps what might get challenging is when you're trying all these different things, you need some way to like benchmark how successful it actually is. You can't really rely just on like the loss curve on the training output or whatnot. it actually needs online validation to say, yes, it is 85% successful the whole way through. And that's because it's an online process with like feedback from the system as it occurs in real time. And if the robot messes up one frame, it can ruin the whole episode, right? So if you have a simulator for this, or maybe set up Isaac Lab for it and roll out the experiments that you're doing, validate them first. That's kind of what I do. And do test LARs on your Jetson or like an AGX over, and that can actually do the training, scale up the training. Presumably, you're going to have a lot of test data from all these people coming and doing it. So it could be
the real world data and the simulated data are both really important, because sometimes simulated data doesn't knows about some
the real changes, right?
the real changes. So according to my
that is one thing. Yes, sim to real, certainly something that we want to be able to do is commonplace, right? I think in order to achieve that, you have to also be able to do good virtual twin, which is like a whole other part of this whole workflow that has been pulling in the whole more like art side of generative AI, including like nerves and neural reconstruction and all of that. So the robot first scans its environment and does like the pose estimation, and then neural reconstruction with nerves, or Gaussian splatting is what it is. And we covered this in the research group recently with Fruit Nerve came out, and that started to be like, oh, people are using this for edge and like robotic stuff, and now it's generating the environment scan that ends up getting used in the sim to train the robot, and has more accurate sim to real like characteristics in it. But that all aside, you could use it just to validate your software changes, or be like, hey, I changed it from absolute to relative positioning, and it increased the success by like 10% in the sim. So it should see a similar one in the real train model. That's even if you don't have the sim to real like working. It will keep you way more sane to validate it in that known good sim environment. And resetting all the testing and stuff takes a lot of time. And you can also parallelize the sim and run like multiple tests at the same, because all these things to check off. That's how it ends up taking weeks and weeks to develop this, if you're trying to do all these little micro changes to the architecture, training regiment, stuff like that. And I believe I heard once that for like big models that full teams train, it typically takes at least like 21 to 25 days is like how long it'd take for like a real like model to do it. And I couldn't believe that based on like what we've done, even going like has full speed on it. That seems about like on the money actually. So in order to like shorten that to reasonable lengths, and keep the scientific rigor about it, because once you start going down these different things, it makes a big difference what you try next. Having those but like simulated environment and the real one to test it on seems really nice to be able to make it all work. And
partners will also port their arms into the Isaac sim environment later.
Okay.
And we will do the part of the work, and we will see how it compares to training by real data or the sim.
That's a great, that all that stuff is really valuable to know and like share with the group of all these different things people are doing. And by virtue of trying a lot of these different things, like the Diffusion Policies Act, the VLAs, all the latest ones, I run a lot of the different simulators through Jetson, even, and got a lot of them to compile. So it's been interesting to see how all these projects are doing it. And there's a few of them that do bring them all together. Those being like Lay Robot, the RUMS project from PyTorch guys, and Hello Robot. I believe that there might be a couple others, but those seem like it'd be like the main ones. Although if you hear others, let me know. And Ross also. So like try to standardize this around some that will help people be able to swap out which models or data sets and stuff. Because like once you get your data set, you can should just be able to drop the latest and greatest policy in there that runs in your compute constraints and not necessarily care so much about is it a VLA or a diffusion policy or, action tokenizer, whatever it might be, or a mixture of experts of all of those. And then just which one like performs best for you. So, and we're going through those other ones that have been optimizing those too, including the diffusion policies. And a lot of them do have like their trade-offs of which ones are best. The diffusion policies seem pretty good for behavior cloning of like a single task, whereas the language ones like the VLAs, they're multitasking and have some language abilities. And I think one thing people have found with the VLA is like the vision encoder part is very important to those. So like Dino gets used a lot, and putting more emphasis on how big the VIT is versus the LLM, because these they don't need like super advanced language here, but they do need some like reasoning. Then the higher order reasoning you start to see with like the Isaac Ross Rosa project. We started working with those guys from NASA JPL, and they've been really great and supportive of all the community efforts. So like consider using that in this too. That could be really cool to see, as that's how I've been like kind of thinking of it, as like that Ross agent is like the higher level controller that you would talk to, right? Or command, and then it would invoke whatever behavior is needed or set other things. And so that's like the high level controller, long-term planner versus like the short-term one, because you still need something to do the actual tasks. And I think a lot of that comes out of like the RL community. So right now is an interesting time because you see a lot of the RL roboticists, all their policies and that whole flow, like you would see in LayRobot or the OpenAI Gym, the whole like step, get observation, that like control loop, kind of merging with a lot of the generative AI side, where you get like the LLMs, the multimodal VLMs, and those tend to be much larger, higher resolution, whereas a lot of the reinforcement learning stuff is still at 224 or smaller resolution, 84 by 84. So their policies are still quite small, can train on single GPU in like a couple hours or less, whereas like OpenVLA was 30 days on a big cluster, So it's a whole, and now we're trying to make smaller VLAs and get like kind of in the middle and get what capabilities like we need for like the utility mouse. And then mostly they're working on making it all generalist and foundational, so maybe don't need so much fine tuning or whatnot. But it would seem doing it for your specific one, as long as we can make the workflow easy, anybody can go and use that. It's just more specific to like what tasks you need. And as long as you have it set up in an intuitive way to teach the robot, have the people teach it in person or whatnot, it seems like a viable way to make it work. So I think you'll learn a lot from this whole thing you're doing with having people come in. And almost more of the social part too, like how to do these intuitive workflows. So I would love to like work together on that to understand what is the best way to teach robots essentially, and collect that all in a low friction way. Yeah. And hopefully it can even be like maybe day to day you can get set up so you train on the latest night's data, and the next day test that with them or have them refine it and collect more episodes in an area that it needs additional help or training on, and take it like day by day and see how the intelligence improves over time. Obviously that's like a big step, but in general my recommendation is like take it one step at a time with everything. Any changes that you make to like training code base or things, especially with like the VLAs, and the difference there is like, it takes in the whole llama transformer stack essentially for it, and versus some of the other policies are way simpler. And that's why some of those meta frameworks are able to like re-implement them and be pretty accurate. Some of the other ones, it's more likely to use the original code base. Like when I was doing OpenVLA, it was with the original code for it. And then I did inference in a different one, but the training was always with like the original code for that. So now we're starting. There is much better support for fine tuning in like Hugging Face transformers and TRL XTuner library. That's what I was actually just gonna play around with tonight and see how that worked, because Intern VL, those guys use XTuner. And Intern VL comes out, they've been going out with some awesome stuff. And that NVLM model that came out, that was like a fine tune of their Intern VL. And they came out with this XTuner that it lets you train these from scratch too and combine different ones. So if I want to say, yeah, I want to take the Llama 3.2 SLM and combine it with Dino, or the Intern VL guys have like a huge VIT, like a 6B VIT, that 448 resolution. That's what the NVLM guys use too. And like, okay, well, why don't we like hook that up to like a little mini SLM, like big eyes and like little reasoning brain on it, right? And just see, or it would love to have a chart of like, hey, this is what it does with this VIT and this combo, and just like characterizing all this stuff is really valuable to understand how it all works and what makes it work for you. And that's why we have people at the group that come and share their results. So yeah, it's great that you're doing this, and hope that we
Thank
can.
you for sharing, Dusty. I think we are going to run out of time. So
Yeah. Okay, thank you so much. I look forward so much to hearing about your experiments and stuff.
yeah,
Thanks.
thank you for sharing so much about this part for the robotic areas.
Yeah.
So we still have a round for showing more deeply about the hardware side of our reComputer Mini. So I think we will back to our live stream.
Yes, I look forward to, yeah, and the reComputers are great. All right, thank you so much.
Thank you so much.
All right, take care. Thanks. All right, keep it up.
And for everyone in our live stream, so now let's back to our desktop. So I think we have our reComputer Mini series already on our desktop. So you could see here, indeed, for the reComputer Mini, we indeed sell it on. So this is the basic, the smallest unit.
Yes.
This is smallest unit. Indeed, it just has one layer. The one you have seen on our beside our robot arm is indeed a.
It's with the expansion board, right?
Yeah, it's with this part. So
Yes.
this is an optional one. So
we'll sell it in separate ways. So the base one is the first, and then you can also customize for the extension board, right?
yeah, cause so let's take it apart directly here. So on expansion boards, so there are really much signals available to use. So firstly, we still have to talk about the carrier board first. On carrier board, these are limited functions, because for the small size, indeed, the size limited functions. So on this side, these are the data and power connectors. So you can see XC30 connector power input, two USB 3.2,
right.
one USB 2, and the two other are UART.
Okay.
And
do we have an Ethernet on this part?
Oh no, sorry, there's no Ethernet on this part, but we have two other connectors.
Okay.
So micro B is for the flash. So for flashing system, well, the Type C is for. So this is not a usual Type C. So this is a really powerful one. We have both USB 3.2 and this P display built in. So you could definitely, if you have any monitor use a Type C input, you could directly cut.
Okay.
And you have it. So this one will be really compact and powerful. So on downside, you could have this SSD, and this part underneath is the the 60-volt power input converter. So any any robotic battery system, like 48 battery
Yeah,
is not
that's
only
enough.
So on these three parts is where the expansion goes. So within these connectors, there are PCIe, Ethernet, CAN, SPI, I2C, and all the power voltage you will need. So you could directly put it on.
Oh, so I saw the Ethernet port is
Yeah,
over
the
here.
Ethernet port is here. There are two reasons we put Ethernet on the expansion board. First, the Ethernet port is really big.
Okay.
It's the full-size RJ45 port is really big, and another reason is that sometimes you don't only need one Ethernet port. So maybe you want to have like a router or switch chip built on this expansion board. It's doable. So just try it out. And also the CSI signals is also on this. So you could use this board to expand for more USB port and more CAN. There are indeed two separate channels of CAN. This originally just shipped with one channel of CAN.
Okay.
So that's originally here. We have used this XC32+2 power connectors. So there you could definitely use one wire to solve also power and signal transmission. Well, but in many robotic systems, one channel of CAN is not enough for usage.
Right.
Yeah, so people need to more CAN. So we have another separate channel of CAN here. And beside this is the I2C connectors. And on side Ethernet, SD card slot, SIM card, and SPI. So afterwards, you just need to the frame and just close and then just screw it on, and you got a new, more powerful reComputer Mini.
Yeah. So for now, this is the full function of the reComputer Mini. It's the first version of our product, but later on we may cut some features on it, right?
So this is an early view of this reComputer Mini.
Right.
So what will be on the expansion board is still may have some slight changes, like maybe remove the LTE module in it. Well, maybe so. Stay tuned. Stay tuned. We will update the news in our core channel.
Yes.
So this big one, and another details we have made is about the mounting holes. So all these mounting holes are can't be through. They are not through holes. So we want to protect the components within it. So you don't need to worry about your stuff to directly add a really long screw and boom, your original.
Just go through all of the camera board and
then
module.
you're gone.
Okay.
So let's switch to the features. So just a summary of all ports, and also you can scan code to get the data sheet. And so I think this is really a lot of stuff.
Yeah.
Really.
Hopefully you guys enjoy this today's topic. And last but not least, we want to share the giveaway.
Yeah,
right?
I think we couldn't let people wait too long. So now it's the giveaway time.
Yeah.
So today's lucky guy will get not only the reComputer Mini, but the reComputer Mini with Orin NX 16 gigabytes, the most powerful one. Try it out. Our heat dispension design will amazing you. Yeah.
So we'll share a questionnaire link in the chat box, and also you can see it on the screen, on the right screen. So you can scan the QR code or click the link to join the questionnaire. So each one of you participate in this questionnaire, we will select one lucky winner to win the reComputer Mini with Jetson Orin NX 16 gigabyte module, right?
Yeah. And so take your time, scan code, don't miss this lucky draw. And we should talk more about this part. I think we have missed it. So let's cut off the power here. And So today's robotic arm is still not the full power one. I think they say they will update it. On what part? CAN, I think.
The CAN maybe?
Yeah. Yeah, so currently this model is running on RS-485. So, but we didn't design any RS-485 on this board. So if in the future version it will be powered by CAN, then the developers could directly using one XT30 2+2 wire, the CAN and power combination wire, one to this, one to the router, and then the whole system is done.
You want to show the router here?
Yeah, this router. This router also was provided by a partner. so many sponsorship here.
It's really useful.
Yeah, it's really useful. This is a really powerful router, and I think it's really special. The ones you won't see commonly in the market. It was especially designed for robotic applications.
There are so many Ethernet ports there.
Many Ethernet ports. LTE module could be built in, so it will have dual channel Wi-Fi and also the LTE like 4G or 5G available.
Right.
And what's the most important that is this router has CAN. This CAN interfaces, but how it works, according to their claim it will work with the computers, the traditional computers without CAN interfaces, like x86. Raspberry Pi, maybe the Intel NUC, yeah. So they have provided a package. So you just directly connect it to your computer with this Ethernet and install the package. Then you will be able to directly send CAN message through the Ethernet, and it will convert to CAN automatically. So I think it's really special. So if any of you is interested in it, you could call us. You can contact us, and we will introduce this one. So, but this is not really the general.
Yeah, that's suitable for this kind of robot arm and also the edge devices connection, right?
Yeah. So I think it's all of you should have already done with the lucky draw QR code. So maybe we have almost reached the end of, this is the real end of our live stream.
Yeah.
So if any of you is interested in anything it has shown in today's videos, please make sure to contact us in Discord or through the email. So what's our email?
So our email, just contact us at hai@c.cc. And also join the questionnaire. We will now show the result, the lucky draw results today, but we will keep the questionnaire for a few days and also show the result, the winner results through the email or through our SNS, the social media account. So just stay with us, stay tuned.
Maybe we should check about the chat room. I think we have been so many demos today. So I think I have missed the chat room.
Check out what's the question about our audience, how they feel about our demos there.
Oh, there's too many.
Just pick one.
Just pick one. So what's that router? English, please. Oh,
English.
Sorry, I still don't have a model name.
Okay.
But you could contact us. We could introduce the supplier to you.
Okay.
Yeah. DIY router with open write inside, so it's not formally released yet.
Yes.
Same like reComputer Mini.
So it's like an inner test.
yeah, inner test. So if you are interested, please let us know. And any other. Oh, I think our partners, our staff, our teammates had already answered most of them. So okay. That's fine. It's included in Mini. Okay,
so thank you all for joining us today. We want to share more cheap solutions for you guys and also the software, the ecosystem software solutions together, and also combined with our Rethink Edge Jetson devices.
Yeah, I think we haven't make everything really clear in this live stream because we have the chases, the robot arm, the VR, and everything. So
if you have any ideas about the applications, and also if you have any sensing sensing accessories that you want to compatible with our Jetson devices, just contact us and show us the possibilities. We want to make sure you have the.
We also have many robotic partners available here. So if you're looking for kinds of robotic solutions, come to us. There are algorithm provider, hardware provider, also like solution provider.
Yes.
Okay. So, thanks for all of you coming today, and thank you for watching, and thank you for everyone.
Thank you so much. Have a nice day.
Have a nice day.
Bye-bye.
See you next time.